Start.
Good morning all. Now we are going to discuss about the Karnaugh Map. In short form we can call it as K-map. So these K-maps are mainly used to simplify the given Boolean expressions. So Boolean expression can be simplified by using two methods. One is Boolean expression method by using expression that can be reduced, and other method is K-map. So here we are going to discuss about the K-map method. This K-map can be used based on the number of variables.
Sir.
Here we are going to discuss about three types of K-map. First one is two variable K-map, and the next one is three variable K-map and four variable K-map. The variables may be either A and B for two variable or PQ. That depends upon the individual. We can fix the variables. Here three variable we can fix it as A, B, C or anything. Similarly for four variable also we have A, B, C, D or other variables we can be considered. Now we are going to design the K-map, that is design of K-map. Here that n represent the number of cells, or we can call it as number of variables. So 2 power, for example, if you are taking 2 power 2 as our design, here we can have 4 cells, and this n is, here we have 2, so that variables are 2. Good morning everyone. Now we are going to discuss about the structure of two variable K-map. The variables are A and B. This is how we are designing our two variable K-map. So here it can have 4 cells. The cells can be represented with 0, 1, 2, 3. How this can become means that is nothing but 2 power 2 equal to 4. So for this 4 we have to write in binary numbers as 0, 0, 0, 1, 1, 0, 1, 1. So according to this, the cells can be designed. That is 0, 0, that is nothing but decimal number 0, and 0, 1 can be represented with 1, 1, 0 can be represented with 2, 1, 1 can be represented with 3. This is our two variable K-map structure. Next we move on to structure of three variable. So 2 power 3 is equal to 8 cells. So the number starts with 0 to 7. So this is how we are fixing that number. Here we can find out one changes, the like here 0, 1. We know that the next cell, the next cell can have 2, but here we are using 3. Why? Because means in the design of K-map, each and every adjacent cell should have only 1 bit variation. So according to that, the cell shuffling has been done here. For example, if you are taking the first cell and second cell, if you are comparing the bits and comparing the variables, only one bit is changed here. You can see the difference. Here we have 0 and here we have 1. Similarly, the MSB bit, both the cells we have only 0. So single bit variation. Similarly, instead of using 1, 1, if you are putting 1, 0 here, if you are comparing this 1, 0 with 0, 1, we have 2 bit variation, that is LSB bit and MSB bit of both the cells can be varied. So that's why we are not using 1, 0 here. So 1, 0's equivalent decimal number will be 2, so 2 will be fixed here, and instead of 2 we are putting here. If you are comparing this 0, 1 with 1, 1, we have only MSB bit can have single bit variation. So we are fixing 0, 1, 2, 3. Similarly 4, 5, 6, 7. You can compare these two cells again in the second row also. Likewise, we have to design our three variable K-map. The same instruction will be followed for four variable also. So here also each cell should have only single bit variation, and totally 2 power 4 equal to 16 cells. So the cells numbering starts with 0 to 15. Here also the row wise third row and fourth row will be shuffled. Similarly in the column wise also third and fourth will be shuffled according to get the single bit variation in each cells. You can see here. Here we are taking about the two variable K-map. So this is the K-map of our two variable. We are taking variables as A and B. So we have 4 cells. The cells are represented with 0, 1, 2 and 3. In the first row we are taking 0 here. So the combination may be 0, 0, 0, 1, 1, 0 and 1, 1. So 2 power 2 we have 4 cells. And 0, 0 combination we are taking A bar and B bar. And this for cell 1 we are taking the row wise A bar and column wise B. So A bar B. Similarly cell number 2 that can have row wise we have A and column wise we have B bar. So A B bar, and cell number 3 can have the variables of A and B. This is for 2 variable K map. And the next one is 3 variable K map. The variables are A, B and C. That is totally we have 8 cells and 3 variables. The cells are A, B, C. So the cells can be represented 0, 1, 3, 2, 4, 5, 6, 7. Why these 2 cells are shuffled here means there will be one condition. Each cell can have single bit variation. For example, if you are taking the first cell and second cell, the first cell we have 0, 0 and the second cell we have 0, 1. So we have only 1 bit variation in the LSB column. Similarly, if you are taking this 1 and 3 cell, these 2 cells also we have only 1 bit variation. That is, here in the first MSB bit we have 0, here also we have MSB bit 1. So totally we have 1 cell combination. Instead of putting 1 1 here, that is 3, if you are putting 2 here, if you are comparing with the previous cell, that is 0 1 with 1 0, both the bits are varying. So that's why we are shuffling these cells in this column. Similarly, the second row also 4 5 6 7, you can compare this 5 and 7, you can have the variable single bit variation. Similarly, 6 and 7 also we have only single bit variation, that is the LSB bits. If you are changing this 6th bit cell into this position, again we can compare these two and we have 2 variables. That's why this K map can have, each cells can have only single bit variation. This is for 3 variable K map. Now we are discussing about 4 variable K map. The variables are A, B, C, D. So totally we have 2 power 4 16 cell combination, and it starts with 0 to the maximum of 15. Here you can see the here we can see the changes in the third row as well as row wise third row and fourth row can be shuffled. Accordingly, the column wise also the third and fourth row can be shuffled due to the single bit variation. So for example, if you are taking the first cell as 0, here the row wise we have 0 0, that is represented with A bar, B bar, and CD, the column wise we can have CD, that can be 0 0, that can be represented with C bar, D bar. So the first cell can have the variables of A bar, B bar, C bar, D bar. This can be taken from row wise variable and column wise variable. Similarly, the second cell, that is cell number 1, can have A bar, B bar, C bar, D. How this comes means, the row wise we have A bar, B bar, and the column wise we have C bar, D. So we are taking A bar, B bar, C bar, D. Similarly, on the next cell, that is cell number 3, that can also have A bar, B bar, and the column wise we have C, D. Likewise, we have to fit all the variables in all cells. This is how the K map can be designed.